Hi friends, this is your Max Bro channel. Now we're going to see the GAUSS-SEIDEL method. It is one of the method in a numerical analysis. Our question is solve 10x plus 2y plus z that is equal to 9, 2x plus 20y minus 2z that is equal to minus 44, minus 2x plus 3y plus 10z that is equal to 20. This is the three linear equations. Solution. The first equation is the first one, second equation is the second one, and third equation is the third one. So here in the first equation, x value want to be bigger than the other two coefficient. In the second equation, the second coefficient must be greater than the other two coefficient. In the third one coefficient must be greater than the other two coefficient. So as per here, the 10 is a greater than other two, 20 is greater than other two, and 10 is a greater than other two. So finally, the three equations are verified. So here, in this equation, the first equation is a 10x plus 2y plus z that is equal to 9. So here I need the value of x. Therefore 10x that is equal to 9 minus 2y minus z, and x is equal to 1 by 10 inside the bracket 9 minus 2y minus z. The same from the second equation I am going to solve the value of y. So y that is equal to 1 by 20 inside the bracket minus 44 minus 2x plus 2z. The same from the third equation, I am going to solve the value of z. Therefore, the value of z is equal to 1 by 10 inside the bracket 22 plus 2x minus 3y. So here we received the three values, that means x, y, z. So now we are going to do the iterations. The first iteration, second iteration, and third iteration. The first iteration notation is the x power 1, y power 1, and z power 1. So here for our first iteration x power 1, put y is equal to 0 and z is equal to 0. So the x equation is the 1 by 10 inside the bracket 9 minus 2y minus z. So I'm going to substitute the value of y as well as the value of z. The solve. Therefore the x power 1 that is equal to 0.9. So next the second one is the first iteration of the y. The equation of y is 1 by 20 minus 44 minus 2x plus 2z. Here I need the value x as well as the y. Here the value of x is the last, that means the before value, that is the x power 1 value is 0.9. I am going to apply this one. I don't know about the z value, so in this place that is the 0. So here by using the calci we want to solve this one. At last the iteration of the y is minus 2.29. So now I received the value of first iteration of x, that is equal to 0.9, and the second iteration of y, that is equal to minus 2.29. So the third one, I'm going to take the value of z is equal to 1 by 10 inside the bracket 22 plus 2x minus 3y. So now I need the value of x as well as the value of y. So x value from that first iteration, the value of 0.9, from that iteration of y, that is the minus 2.29. So here I want to substitute the final value of the z iteration is 3.067. Therefore, the first iteration is completed. So now we're going to see the second iteration. The second iteration is the x power 2, y power 2, and then z power 2. The same as usual, the value of x. So value of x is x is equal to 1 by 10, 9 minus 2y minus z. I am going to substitute that one. So here I need the value of y as well as the value of z. So value of y is I already know from that last, that means before equation value is y power 1 that is equal to minus 2.29, and z value is z power 1 that is equal to 3.067. So here I am going to apply the both value. So second iteration of y is 1.051. So the second iteration of y, the same the y equation. So here I am going to substitute the value of x as well as the value of z. Value of the x. So here we need to concentrate the before iteration value. Okay, if I am solving the y power 2 means the before iteration, that means the latest what I received. So value of x power 2 is 1.051. So z value is in before what value of z I received. So z value is 3.067. So I'm going to substitute the both one. The value of y is equal to minus 1.998 at last, that is the z power 2, that means second iteration of z. As usual, the equation of z. So here I am going to substitute the x as well as the y. The x value is the last value, that means before value is 1.051 and y value is minus 1.998. The both value I am going to substitute. So value of z power 2, that is equal to 3.01. So here x power 1, y power 1, z power 1 and x power 2, y power 2, z power 2. So can we compare this one 0.9, 1.051, second value and third value. The both iteration is similar. So now we are going to see the third one for a better similar. So now we are going to see the third iteration, that is the x power 3, y power 3 and z power 3. So here the third equation is 1 by 10. As usual, the x equation is the 1 by 10, 9 minus 2y minus z. So here I am going to value of y as well as the z. That means the before iteration value. The value of y is equal to minus 1.998 and z value is 3.01. So I am going to apply here. So I received the x power 3, that is equal to 0.998. So here for our third iteration of y. Okay, the x as well as the z. So x value here, the last, that means before value of x is what? 0.998. The before value of z is what? 3.01. So I am going to apply here. In the same method I am going to apply the value of z power 3. So here I receive the value of x power 2, y power 2, z power 2 as well as x power 3, y power 3, z power 3. I am going to compare the both. So here 1.051, here minus 1, here 0.998. Next here minus 1.998, here minus 1.999. Here 3.01, here 2.999. So for our better result, we are going to do the fourth iteration. In the same method, I am going to proceed for the fourth iteration. Therefore, the fourth iteration value is x power 4, that is equal to 0.99999. Y power 4, that is equal to minus 2. Z power 4, that is equal to 2.999. Okay. So at last I am going to compare the third iteration as well as the fourth iteration. So I am going to write the third iteration. The third iteration value is 0.998. So can we write approximately equal to 1. So here minus 1.999. So I can able to round off this one, that is the 2. Therefore the approximate value of y power 3 is equal to minus 2. And z power 3, 2.999, the round of values approximation of 3. So here x power 3 value is a 1, y power 3 value is a minus 2, z power 3 value, that is the 3. So next x power 4, the fourth iteration. So this one is a round of value is a 1 and the second one is as usual minus 2. And for a third one, that means z power 4 value is a round of is a 3. So now I am going to compare the x power 3, y power 3, z power 3 along with the x power 4, y power 4 and then z power 4. The values both are got similar. 1 minus 2, 3, 1 minus 2, 3. Therefore, I am going to finalize the value as x is equal to 1, y is equal to minus 2 and z is equal to 3. So that's all our GAUSS-SEIDEL method.